All right, guys. Let's get to work. Trying chapter 6. The beginning might seem a little familiar because it goes deeper into the pre-calc stuff, and then we'll get into solving triangles and whatnot eventually. And I'm most likely going to have an exam on chapter 6, and we'll be done with chapter 6 pretty quickly. So that means we'll have another test very soon. I don't know when yet. Keep that in mind. When we get close to the end of 6, we'll probably start reviewing. Okay. So today we're just going to do 6-1. Take it easy. First day back, you know. Angle AOB consists of two rays, R1 and R2, with a common vector, which the book calls O. All right. So here's O. And I believe we mentioned this before. This is my initial side. And then we have the terminal side, right? R1, R2. But then we said we're going counterclockwise. That is positive. A positive angle. Now, if we go the other direction, it's going to be negative. So here's O, my initial. Here's R2. To go in this direction, we said it's negative. Okay, so all that's still in the background. We give some definition as to what is a radian, a bunch of formulas, and then we'll start the examples. So first definition. So if a circle of radius 1 is drawn with a vertex of an angle at its center, then the measure of the angle is in radians and is the length of the arc. Length of the arc that subtends the angle. tens. Yeah. Okay, so also a side note, a radian is technically a unitless measure. So if I multiply a radian times feet, it's still going to be feet. Does that make sense? It doesn't change to something else. So even though they're called radians, which feels like it's a unit, sort of isn't. Okay. So let's keep that in mind. It's not going to mess up your conversions or measurements.
Wait, what does that say? Definition of radian what? Measure?
Radian measure. So let me give you the math formula here for radians. The relationship between degrees. So we're very used to degrees, even though they're kind of messed up. Radians are a more useful unit because we can do calculations with radians. Can't really do that calculation with degrees very often. But most of the time, if you're doing a real life problem, you have to convert. So we have to know that 180 degrees is pi radians. 1 radian or 1 rad is technically 180 over pi degrees, and 1 degree is technically pi over 180 rads. Okay. All right, conversion factors. This is where you're getting when the homework first starts. The first like 10 problems, they're just converting degrees to radians. So it's pretty straightforward. You guys taking chemistry yet? But you've done it at some point, right? High school maybe. You guys remember doing conversions in chemistry?
Yes.
You had like ounces to liters to milliliters. Do you remember all that? Yeah.
The one that equals
Rads, RADS. So conversion, we're just multiplying by fractions, right? Like if you wanted to go from feet to inches, you would multiply by a conversion factor. I know technically you would just do the division on a calculator and get the number, but properly the conversion would be multiplied by each fraction, cancel your units, write down the new fraction. So it's basically the same deal. If you've done it before, then this is the exact same thing. If you haven't, well, we're going to do it now. But nothing that crazy, just a basic conversion. So degrees to radians, I'm going to make it simple for you. Multiplied by this. Multiplied by pi over 180 degrees. Okay, 2 radians to degrees. Multiply by 180 over pi. And I'll show you a trick to remember it, but of course you can put it on a formula sheet if you want. It doesn't matter. And I'll wait a bit to turn the page. Any questions on this page or something you can't read carefully?
yeah, I can read the part definition of radian.
Yeah, radian measure.
Measure.
Yeah.
Okay. Great.
So if a circle of radius 1 is drawn with a vertex of an angle at its center, then the measure of the angle is in radians and is the length of the arc that subtends the angle. So subtend means sweeps across. It's a fancy word for sweep. So if you're creating an arc, you're subtending something. These are all the relationship between radians and degrees. Here, these three. And that's where these come from. It's kind of like when you divide 1 foot by 12 inches. That's a 1. It's equal. That's what this is. Any other questions on this page? No, wait a bit. I'll turn the page. You got school on this page. Conversion factors?
No.
Oh, right here.
Yeah.
RADS. It's abbreviation for radian or rads. All right, 2 more formulas and then we'll do some examples. So in a circle of radius r, circle of radius r, the length s of an arc that subtends a central angle
So what is the subtext?
just sweeping across, like here, let me draw you a picture. So if you're going up to some angle and you're going across this distance, that theta, that's subtending the angle. And that distance is called s. That's the arc length. And you find it by using this formula. But notice that theta must be in radians. So do not use degrees when you're calculating this formula. It's going to be wrong. Same thing for area. Area of the circle has the same intro, so I'm not going to write it again. Area of a circular arc. The same garbage. the area will be equal to 1/2 r squared theta. So basically, they look at this sector as just a chunk of the circle. When they say sector, it's kind of like a little slice of the pie, right? The area of that slice is this. That all weird. Speed. Angular speed, theta over t.
Is that under the area of the circle too?
No, new formula. And another one. Linear speed. Usually we use omega to define this. Let me write that down here. Looks like a W. In the book, we use omega. And they use V for linear speed. So T is time, obviously. S is the arc length. And theta is the angle. All right, so that's all the formulas you're going to need for this section and definitions.
For all of these, data has to be in radians.
Yeah. So they're gonna be some word problems, and you can't use degrees. Okay. You have to change to radians. So let's practice converting back and forth. Convert the following. That's all weird. 60 degrees to radians. Now, technically, you know these answers by looking at the circle, but that's not the point because they're not always going to be pretty degrees, pretty angles, right? It could be like 75 or 42.7. So the process is what matters. So the way I remember the formulas, or which ones to use, is you put what you want to cancel on the bottom. So I'm multiplying by the conversion factor. I mean, I wrote you a note and told you to use this one to go from degrees to radians, right? But the reason is because you want these degrees to cancel. You're going to have 60 degrees pi over 180 degrees. So these degrees cancel. So now in radians, so that'll be 60 goes in above pi over 3 radians, right? So this is the angle, that's the number that you would use for like one of these calculations up here, which we'll do later.
So what happened to the 6? Oh, no.
You see it? That's all you're going to do every single time. If you have some degree that they give you, multiply by this. And you should get something pretty, or if it's not on the circle, it might just be some weird fraction, which is okay. You could get like a pi sevenths or something. Nothing wrong with that. Convert, let's do another simple one. Pi 6 to degrees. I know that you probably already know the answer. It doesn't matter. so you take pi over 6. Now I want to cancel the pi and be left with degrees. So I'm going to put the pi on the bottom. See what I mean? So I'm using this factor to cancel this guy. So now I got 180 degrees pi over 6 pi. 180 divided by 6.
30.
Yeah, 30 degrees. So that's our unit. It's not nothing crazy, right? Does that make sense? Or
Yes.
let me know. Let me know if that's crazy or strange. All right, so let's move on to coterminal angles, unless you guys have questions.
Are we going to the next chapter?
No. Just a different topic. Still a lot to talk about on 6.1. Got to use all those formulas, you know. Coterminal. So coterminal is something we've talked about, but not officially done. Find the coterminal angle, or find the angles that are coterminal to 30 degrees. All right. So it helps to have the circle. So here's 30 degrees. Right? Now, all coterminal means is what's an alternate angle that gets me to that spot. That's all we're saying. So if you add 360, do you agree that you're going to land on 30? Right? 30 plus 360 would be the same thing. Let's go around, back to 30. What if I subtract 360? Same deal. So coterminal angle would just be that result. What is another angle that gets me here? Well, 360 plus 30. So 30 plus 360. Does that make sense? Do you see what coterminal means? That's all it is. Are there any questions on that?
Negatives, like negative to 30.
Yeah. Let's go ahead and do that. Let's write down a couple of them. So 30 degrees, if I add 360, I get another angle that is the exact same spot. Right? If I add 2 circles, I get another angle that's the same deal. Right? And as you guys said, if you subtract, you can get there too. All these angles would be coterminal to 30 degrees. That's what coterminal means. So they say in the book or whatever in the homework, just find another one that's the same location. Does that make sense? Okay. Move on to something else. You guys cool on coterminal? Let me know. So yeah, the next, so first we'll start off with conversions on the homework, and they'll ask about coterminal for a little bit, and then they get to the word problems, which is this section. Find the arc length of a circle with radius 10 meters that subtends a central angle of, I don't know, yeah, 10 meters, 10 m meters. Let's pick a random angle, I don't know, 40 degrees. So arc length is this formula. Let's go to our theta, but our theta is in degrees. We have an r, we have a theta. So change it. So multiply by the conversion factor, pi over 180. The degrees cancel and the fraction reduces. What does this become? Yeah, 4.
1/4.
Oh, you're using the mixed number. What about the regular? Let's keep it this way. Pi over 9. So 40 goes into this, I'm sorry. The zeros cancel. 2 goes into this twice. 2 goes into 18 9 times. So we can use that guy now. So it'll be 10 meters times 2 pi ninths. So it's going to still be in meters. It's not going to change. So that'll be 20 pi ninths meters. So as a decimal, what is that? Okay. 6.98. So that's the distance S of the arc. Any question on example 3? I have a second. Find the area of a sector with a central angle of 60 degrees. If the radius is 20 meters. Find the area of the sector with a center angle of 60. If the radius is 20 meters. Here's a formula. Okay, so we got R equal to 20. And we got theta equal to 60. Technically, we did this earlier. We multiplied by pi over 180. And we got pi thirds, right? So that's going to be 1/2 times 10, or actually 20 meters squared times pi over 3. Twenty squared is 400, right?
Yes.
So this will become meters squared units. So it's going to be area. So half of 400, that's 200. So I'd say it's 200 pi over 3 meters squared, which is approximately what?
209.
209.44.
Yes.
Okay. Any questions on area of a sector or arc length? All right. Notice how it's very similar to the area of a circle formula, right? Right, it's pi r squared. So if my angle was 2 pi, which is a full circle, that 2 would cancel to half. It would give me pi r squared, which would be the area of the whole circle. So it's basically a modified version or a more general version of the circle formula. If you think about it. So instead of a full circle, you can just choose any angle and just find areas of slices. Whatever you want. That's cool on this page. Okay. Let's do a harder word problem and make sure we understand what this stuff means. You guys cool on this page? Be the last example. And then we'll see if you guys have any questions. So a boy rotates a stone in a 3-foot long sling. At a rate of 15 revolutions.
That's, what is that? What? Like,
Yeah, it's spinning a little slingshot thing, like old school sling. It's like a David Goliath kind of thing. So spinning that thing at a rate of 15 revolutions every 10 seconds. Find the angular speed. Okay, and the formula for angular I gave you was omega equal to theta over time. So theta would be how many times we went around, right? Over time, which is 10 seconds. So in 10 seconds, I'm doing 15 revolutions, right? I'm going around and around. But what is a revolution? It's a full circle, right? So isn't one revolution 2 pi then?
Mhm.
So technically our theta is 15 of this, right? Does that make sense? And that all happens over 10 seconds. The actual theta, where does it stop, right? The terminal point, or sorry, the angle would technically be 30 pi over 10 seconds. This is technically right at 0, whatever. Anyway, so this becomes 3 pi radians per second. So this makes sense to you, how we found it. Like using the formula is not too bad, right? But what is angular speed?
So 2 pi is a little bit.
2 pi is 1 revolution, so there's 15 of them. And we gotta use radians for actual word problems, right? No degrees. Degrees are made up. Radians are real. Anyway, so you guys know what angular speed is. Yeah, when you guys hear RPMs, you know what that means, right? In a car.
Notation.
Yeah. So basically, how fast is something spinning? So like if you had like a buzzsaw, how fast is that blade going? That would be angular speed. That make sense? Now that's different to if I take a point on the edge of the blade. How fast is that point going around the circle? That is not the same as how fast the blade is spinning. Is that clear? Okay, so that's what angular speed means. How fast that whole circle is going. Part B. I know this is not physics, so we're not going to go too deep into it, but I do want you to at least understand or remember what that means. On the linear speed.
It could be is for A, B, 3 pi over S. Or like, you have to write the graph.
You could say 3 pi per second, but I put rads per second so it makes a little more sense. It's not necessary. It is understood. But in case it's not understood, it's right there. All right. So linear speed is s over time. So that's the speed at the edge for the blade. So how fast are you going right at the edge versus how fast is the thing rotating? Those are two different things. So you need to find the arc length first. So let's do that over here. S is equal to r theta, which will need the radius of 3 feet. Yes. Theta is technically this, right? Okay. Time. Oh, we don't need time, but I'll write it down anyway. 10 seconds. So this would be 3 feet times 30 pi. That will be 90 pi feet. So 90 pi feet over 10 seconds. So how fast we're going along the edge of the circle? The 9 pi, right? As an approximation, what is that? 28. About 28.27 feet per second. You guys know the difference between angular and linear? Is that okay? You guys able to use the formulas? Let me know if something doesn't make sense. I always found it strange that the edge is a little faster.
That's 57.
53, 57, 63, 65. A lot of these are super short questions, so it might look like a lot, but you can probably do this in like 30 minutes if you know what you're doing. If you don't know what you're doing, maybe a little longer, maybe a little less. Yeah. I just multiply 9 times pi. Did I mess it up? Yeah. There. Yeah, this homework should be pretty straightforward. I'm hoping. All right, guys. Well, we'll stop here. I'm hoping to have your homework's done by this week. And have not started, but hopefully I'll start that today or tomorrow. I'll get those back as soon as possible, but there will be an exam 3 a lot sooner than the last one. I'm hoping I'll know by Friday the date. It's going to be chapter 6, so it's going to be very focused on one second, a few seconds.
This is 6.1.
6.1. So I think we're going up to 6.5 and then down. Yeah, this is homework for 6.5 or 6.1.
All around?
Just for 6.1.
Okay.
They already closed it, and then that's the only thing that's due on Friday.
Did you put it on? Did you make a Zoom?
Oh, I'm about to, yeah, I made a Zoom and I'm about to scan this.
Thank you.
For the exam, can I get like the answers, just the solutions, online, so I can just go back and try solving that?
Yeah, I'm gonna solve them all in class soon. Usually what I do it right after, but because we had the first 4 weeks off, whatever, or 2 weeks, I wanted to wait on it to make sure we're still on schedule. But then when it comes to final review, I'm gonna do every single one and then send you the
Oh, okay, all right. Okay.
Yeah.
Thank you.
Hey, what's up? I might have just seen it today. What was your name? Oh, yeah.
So would it be possible for because I was at the first, and I was like 2 weeks past.
No, it's okay. Yeah, I mean, I wish, do you not use the reminder?
I do.
Yeah, I didn't see your email today,
I
but
didn't know if I could send a message to that or not.
no, you're good. Yeah, I mean, I'm just gonna end up dropping an exam.
Okay.
Yeah, I'm gonna be releasing the grades pretty soon.
Okay. Okay.
Did you do okay on the first one? You
Yeah, I
did
did.
take it. Okay, yeah, don't worry about it.
Okay. Thank you.
Focus on test 3.
Okay.
I couldn't find my test, but I found the reminder I sent you. That was the day of. That was like in the submission comments.
Yeah, I think I remember